A vast stretch of desert glimmers under the early morning sun. The air is crisp, dry, and still. Somewhere in the heart of California, a runway stretches straight into the horizon. This is the home of the most daring experiment in aviation history. A strange aircraft slowly taxis toward the runway. At first glance, something feels unusual. Its nose is impossibly long, nearly 11 meters, almost a third of the entire aircraft. Where a cockpit window would normally sit, there is nothing. No glass, no forward view, just a sleek, futuristic fuselage shaped by science, not convention. This is the X-59, a project developed in secret to solve a challenge that has haunted aviation for decades, the sonic boom. Ever since humans first broke the sound barrier in the mid-20th century, supersonic flight has carried a fundamental problem. When an aircraft flies faster than sound, it generates a shock wave, a sudden, loud pressure wave that echoes to the ground. Windows shatter, animals panic, people complain, communities are disrupted. In the 1970s, engineers believed supersonic travel could connect continents faster than ever before. The era of high-speed commercial flight dawned with the introduction of a sleek, delta-winged airliner that promised to cross oceans in just a few hours. Inside, passengers experienced a smooth, quiet journey. Outside, communities beneath its flight paths endured a relentless, thunderous boom. Opposition grew, regulations tightened, and overland supersonic travel became all but impossible. Even decades later, the question remained, how can humans travel faster than sound without disrupting life on the ground? The answer was not simple. Engineers had tried altering shapes, wings, and fuselage designs, yet the shockwave remained, a stubborn, unchangeable fact of physics. Enter NASA's X-59 project. The goal was ambitious, to create a supersonic jet whose sonic signature would be reduced from a violent boom to something quieter than a car door closing. This meant taking every principle of flight known for supersonic aircraft and rethinking it entirely. To understand the magnitude of this challenge, consider what creates a sonic boom. When an aircraft exceeds the speed of sound, pressure waves cannot move out of the way fast enough. They stack together, forming shock waves along the aircraft's body. When these waves reach the ground, they arrive as one powerful, ear-splitting boom, often exceeding 100 decibels. NASA's engineers took a radically different approach. Using advanced supercomputers and wind tunnel experiments, they studied how shock waves form along every inch of an aircraft. The revelation was that shock waves did not form in just one place, but in multiple locations along the fuselage and wings. If these waves could be separated and controlled, the sonic boom could be softened. Early testing involved small-scale models, only a fraction of the size of a full aircraft. Special imaging techniques made the invisible visible. Shock waves were captured in real time, allowing engineers to see how subtle adjustments to angles and curves could diffuse the energy of the waves before they reached the ground. After countless simulations and refinements, they had proven the concept. A quiet, supersonic aircraft was possible. But proving the concept and building a full-scale, flight-ready aircraft were entirely different challenges. The X-59's design broke every conventional rule. Its most striking feature is the nose, an elongated, tapered structure designed to slice through air, gradually diffusing shock waves. At supersonic speeds, air behaves almost like water. The long nose guides airflow in a gentle manner, much like a kayak cutting through a calm lake, rather than a speedboat creating a wake. The aircraft's engine is mounted atop the fuselage, shielded from the ground below. This unusual placement further reduces the impact of the aircraft's noise footprint. Every detail is critical. Even static electricity buildup on the fuselage at supersonic speeds can interfere with onboard electronics. To counter this, the X-59 is coated with a special anti-static material, similar to high-performance non-stick coatings found in industry. Perhaps the most radical feature is the cockpit. There is no traditional forward-facing window. Pilots rely entirely on an external vision system, high-definition cameras that provide real-time views to the cockpit display. Even in the rare event of system failure, the aircraft is designed with backup visual cues and instrument data that allow pilots to maintain safe control. The construction of the X-59 is a feat of precision. Advanced composite materials are shaped with laser-guided tools. Every curve, every surface, and every angle must meet strict tolerances. A minor imperfection could turn a carefully designed thump back into a disruptive sonic boom. The aircraft is assembled at a highly specialized aerospace facility known for producing experimental aircraft that redefine the boundaries of flight. Currently, only one prototype exists. It remains on the ground, undergoing rigorous testing. Its engine, modified from an existing fighter aircraft power plant, produces enough thrust to accelerate the X-59 to Mach 1.4. The static engine test was a milestone, confirming that this radical design could function as intended. The next challenge is flight testing. Because of regulations prohibiting sonic booms over populated areas, there is only one suitable testing location in the United States, a remote airfield surrounded by desert. Here, NASA will conduct groundbreaking experiments. Residents will not know when the aircraft flies overhead. Why? To ensure that responses to the aircraft's noise, or lack thereof, are genuine. NASA is building full-scale replicas of typical homes and conducting experiments to measure human perception. This is the first time regulations might be based not just on scientific measurements, but on how people perceive sound in their daily lives. The implications are profound. If successful, supersonic travel could resume over land, cutting coast-to-coast flight times dramatically. New York to Los Angeles could shrink from 5 hours to under 3. Routes once prohibited could be reopened, creating new opportunities for global travel. The X-59 is currently scheduled for its first flight in the upcoming test phase. By the late 2020s, NASA will share its findings with international aviation authorities, potentially rewriting the rules of supersonic flight. This aircraft is more than a machine. It represents decades of human ingenuity, the courage to challenge long-held assumptions, and the pursuit of a future where supersonic travel is not only fast, but compatible with everyday life on the ground. The X-59 reminds us that innovation often requires thinking differently, seeing the impossible, imagining the improbable, and building a reality that others once deemed unattainable. The future of flight is quiet, fast, and remarkable, and it begins here in the desert, with a jet unlike anything the world has ever seen.